Okay, in this video, I will show you how to write code for the input capture in timer in input capture mode. Okay, first I will use the timer 1 channel, timer 2 channel 2, channel 1. So in this project, we will what capture the actually we will capture the signal that generated by PE0. No, sorry, by PE12, PA5, PA5. So PA5 we will generate signal. So PA0 will be used to capture, right? To capture the signal of the PA5. So please connect the wire PE0 and PE5, right? And connect the wire like this. Next, okay, go to the clock configuration. Set to any clock that you like, right? For example, you like 50 meg, right? 50 meg. So write 50 meg in your, okay. Okay, next we go to the okay, look at this is very important. So we're going to use the timer 2. So if you check, if I'm not mistaken, this one, you can check it in page number 14, page number 14. So if you check timer 2 is connected to APB1, APB1. Remember that. So it is connected to APB1 timer. So APB1 timer is 25, is 50 megahertz, So the clock, today that. So from that we go to timer. Okay, I will use the USAT to display. So asynchronous. I think this all in DMA mode. In DMA mode. So I set all these parameters, and then go to DMA. At I just want to use the DMA in transmit. If you like, you can add. See. Okay. Okay. So we add already DMA. Then don't forget to enable the interrupt. I like to reduce the USAT to parity to 1, for example. Up to you. If you don't want to, up to you. That's not a problem. Then we go to timer. So on the timers for 401, this I use 401, 401, I use 401. So on the timer, there are a lot. We have timer 1, timer 2, timer 3. As I saw in previous video, timer 10 and timer 11 normally we use for time base. Timer 2, 3, 4, 5, 6, 7, and 9 we can use for PWM. Better we use for PWM. And timer 1 normally we use for what complementary PWM. And timer 2, 3, 2, 4 to 9 we can use for the input capture. Up to you. So click on that. Trigger source, no. Clock source, of course, from internal clock. Internal clock mean the one that we fit here. We fit here. 50 meg. Go back to, then you can choose, because I want to generate I want to use the input capture direct mode at pin A0, pin A0. So I select in channel 1. If you select channel 2, so it goes to PA1. I think it goes to PA1. No. I think this one go to PA2, maybe. So don't use it. Wait. Okay. It as timer 2, channel 2, see? PA1. But I don't want to use it. So I use if you want to use, up to you, but I click on input capture. I click on channel 1. So channel 1 is 0, as what we did already as in our wiring share. Right, P is 0. Okay, next we go to the configuration, right? Go to configurations, to the parameters setting. Okay, first we go to the prescaler, right? Prescaler, and then we have the counter period. For this timer, you see, counter period is 32 meg. You can set any that you like, any that you like. Okay. Okay. So we go to the nucleo, pin and peripherals, and go to the calculating time delay. No. Go to generating clock input for the timer. So we have now 50 meg, right? Exponent 6. So if you want this one to be, say 1 nano, is it possible? Yeah. So we need to divide it by 0.005. But if I want it to be 100 nano, example 100 nano, so we divide it by 5, right? So we divide the prescaler by 5. Okay. So it means that 1 tick is equal to 1 or 100 nano or 0.1 microsecond in this case. 0.1 microsecond. If you want it in exponent -6, so nanosecond and microsecond, it means 1 is equal to microsecond, right? 1 tick. Weight of the timer later on is 1 microsecond. So we need to divide the prescaler by 50. So we go to the prescaler, we set it to 50. -1. Then the counter period is the loop, right? The loop. So it's up to you. But say that I want the loop is 10 million, 10 million. So I put it to 10 million, there, 10 million. Internal clock, no device. Click enable. Okay, trigger event is the reset UG, bit from timer. Polarity, okay, rising edge. See, we can have rising edge. That means at rising edge, okay, of the signal, then it will, okay, rising edge of the signal. Wait. Okay, rising edge of the signal. Then it will generate us the interrupt, right? So it will capture. Another one that we have is a negative falling edge. So it's falling edge, right? Falling edge. The other one that we have is buff. Sorry, this one is falling. Yeah, this one is falling. Then the other one that we have is buff. So 1, 2, 1, 2. So we can use to measure the period, the period here. Oh no, sorry, the pulse width. So when positive, we start. Okay, start, and then this one stop, or end. Start and end of the counter. Okay, so we can use the formula here. So the loop, remember the loop is the number of count that takes for a loop is actually is a number of count, the maximum count, for the timer to roll off. Okay, right. So we go to, for this case now we set to rising edge, rising edge. Then IC selection, direct, prescaler, no divisions, and then the filter, the filter. You can put any value that you like. Let's say 5. So that is actually the filter that filter the the input. So So in this case, uh, means the input is nicely captured. Okay, if there is no noise in your input, then no problem for that. And then go to the MBIC setting, click on timer, interrupt. Okay, that's all. That's all for the setting. Okay, then generate code. All right, then we go to no, go to code. Go to core, source, main, make it greater, make smaller. We are using the user. Then we need this to preposition. Then character. We need buffer. We need buffer to transmit. And we're not using. We don't have receive. We're not using receive. So forget it. Okay. All right. Then I want to have I'm going to use the tick T0, right? Then, all right, so I go here to test string copy. String copy the into tx2 buffer. My test. Then transmit by DMA. UART2, UINT8. tx2 buffer. Size string length. tx2 buffer. Okay, that's all. We want to test. Okay, another one that we want to test is, all right, before we come to this, then we set t node equal to get tick. All right, next we toggle, toggle. If t node less than, hold on, let's go get tick, right? Then we toggle the GPIO underscore T. Okay. Remember, we need to advance the T node after that. Okay. Plus with 100, we say. Okay, 100. So 100 millisecond. Compile. Build. Build. Okay, test your code, your simple code first. Write code is write test add code, or write then write code and then test. Okay. Run. Okay. Go to the term. Serial. Insert your SAM microelectronic. Click OK. Setup. Serial port 15200. Click OK. Okay. Okay. And then run. Okay. So see, same when I reset it, then we can see my tests, right? And the LED GPIO 5 should be turned on and off, right? Turn on and off. So something wrong here. So we check the code. Check the code. Hmm. Hmm. Check for the GPIO, eh? Check for the GPIO. Where is the GPIO? No GPIO setup here, eh? This one. Hmm. So go back to the code. Oh yeah, PA5 is not set. So we set to the output. Reconfigure, regenerate or reconfigure, eh? Regenerate code, build and run. So what we expect when we run, we expect that the light is toggle, right? My test. Then you see here LD2 is toggle at 100 millisecond. Eh? Okay, then we start the code for the timer. For the timer, the first one that we have is the first one that we have is when the loop is out. When the loop is out. Okay, so it's very simple. So if you see the code here, okay, so we need the time period elapsed callback. So when it is out, then we need to increase the loop. Okay, so here we need to have some sort like, actually we can put it in the global, but we can put it here, UINT 32 underscore T, which is the loop, loop, make this easier. I put here loop, INT 32, because here I use start and all that in 32, INT 32. So no need for me to type code, type what change the type, when I need to multiply them in everything. So start to 0, okay. Then we need what we call the callback, whole team period elapse. It's very difficult for us to memorize it. So we go to the driver source, click on timer, okay. See the online, find out callback, elapse callbacks. Hmm. Yeah, this one, period elapse, period elapse callback. Okay, we need this one. Copy this one. You can copy all if you like, but normally I use this. I copy this one only. Okay, and go back to the main and place it here. Oh, sorry. I make a mistake. It should be here. Okay, sorry. So I copy this one. Okay, then in the code, then I will write. I write if okay. So say that we have a lot of timer later on being used, so we need to put this one. Hull has team. Sorry, if has team. Okay, instance. Instance is equal to team 2, I think. Yeah, has team 2, right? We use has team 2, right? Team 2. So team 2. Then what we will do, we just increase the loop. That's all the code, right? As we discussed previously, right? So we have a loop. The loop, here, the loop is increased when the count is more than what? More than the, in our case is more than 10 million, more than 10 million. Okay, the second one that we need is input capture, when it is interrupted, the callback, the callback for the input capture, this one, whole team IC capture callback, this one we need it. Okay, so go back to the whole team, right? Okay, so IC capture callback, this one we need. Copy this one, okay, as usual. Okay, copy that one. Then go to the main and place it here. So we have the second one, whole team. So same, maybe we use a few input capture. So we can see that if that one is come from STEAM2, then we do something. Then we do something inside that. Same like this, this one because of one, then I not. Okay. So if that come from timer 2, then we do the input capture. Alright. So the first thing first. So we need the static bool, right? See, static bool capture, start capture, right? Static int start end and then total. For this case, I use a start cap. But for other case such you have positive and negative, then you can what? You can check if that is net positive, then it means that it is changing from 0 to it is rising high. Rising each. In rising each. If you check the input is the input capture is low, then it means that it is from. Okay, I will modify it later on, then I show you that one. I will show you that one. So this one is we need the start capture, something like start capture. You can use bool, you can use but if you use bool, you need to put here on top include. Oh sorry, dollars. Pound include standard bool. Okay, standard bool. Then you can use bool here, right? You can put it here if you like, right? Up to you. So bool start. Oh. You can see that. Yeah. You can see that. It's actually just 0 1 0 1 0 1. Start capture. I name it as start capture equal 0 when it started, but it must be static. It must be static. Why static? Because when you come back, right? You come back, you must hold that condition, right? This condition. So next that we have is the static, and UINT 22. UINT 22. We have start, comma. We have n, comma. We have 2. Start and end. So whenever this come, right? Whenever it is interrupted, you see in the code here, when it's interrupted, so we need to check the start capture. Okay. Actually, it is depend on us. We the one that said it. Okay. So the first one, of course, if start capture, we just turn it, capture equal 0. Then we do something else. Okay, we can else if, right? We can put it as start capture equal 1, right? Then you can do something. Okay. So when the start capture is 0, then we change the start capture to 0. Okay. And then if it's 1, then we change the start capture to 0. Right. So this is the one, right? Okay. If start capture to 0, then change the start capture. It's just toggling. It's toggling. Okay. You can put it here. Just edit the start. Right. Just the start. Oh, you can put at the end. Up to you. But better if you put it at the end. Because when it's happened, then we need to capture. Right? We need to capture into start. Then we call it start. We capture from HAL underscore team underscore get. Right? Now read capture. Team read capture. Sorry, read capture. HAL underscore read. Read capture value. So that is from has team 2. Then the channel is channel team underscore channel 1, because we use channel 1. Okay, so we copied it. Same when it is well, when it's changed to 1, that means at the stop at the end. So we capture the end, right? End of. We still capture from what? From the CCP, CCP register capture, compare capture register. So n equal to HAL underscore team underscore read, right? Capture as team 2 channel sama team underscore channel 1, right? Channel 1 and okay. So when it started loop, we will set to 0, right? We set to loop to 0. Okay. But when it is ended, so we will use the value of loop, right? Value of loop, right? Value of loop. So we can use the value of loop, right? To calculate the total, right? Total. So we put already the total. No, we can use total here. We can have another one total, right? Right. So total is equal to, right? Total is equal to what? The loop multiply with 10,000, 10 million, okay? Plus with start minus n, okay? Start minus n, okay? Minus n, okay? Okay, that's all. In the formula, if I'm not mistaken, in the formula, so here we have loop n what, minus 20. That one just to set the what? Actually, just to read that one nothing. I always. So you see, all right. That's all the formula, right? The formula, right? So if you see in the formula here, I put 200 here just to because of we have something wrong, right? We need to reduce 20,000 from that. Okay. Then we will transmit, right? We will transmit, print it, right? Print it. So we will print it. Okay. So we will print it. Print what? We print the total, right? The total. So we can print it total. Printf similar to tx buffer, comma, underscore. Oh. Okay. Comma, double quote, /r/n, right? Time equal, right? Equal percent LD, comma, total. Okay. So now we compile or build, then we run, right? Then look at the result. Now we look at the result. Oh, no, it's not working. Okay, it's not working. Okay, next. Why it's not working? Because of when we use timer, remember, when we use timer, we need to enable timer. Okay, we need to enable a timer. So hal underscore team underscore start. That one is time based, right? We have to start in 90. SM2, comma. The one we have hal underscore team underscore input capture. Input capture start input start, yeah, as start IT SM2 channel, channel team underscore channel, okay, channel 1. Okay, compile, build, and run. Okay, so if we read 20 team equal to 20,000, that's why I reduced 2,000, 2,000. 2,000, yeah, like that. So we minus by 2,000. Okay, so, and this one, minus with 2,000. Wait, yeah, now we reduce 2,000, 2,000 micro. Compile, and run. Now we got 2000, right? Right. All right. In the formula, I make a mistake here. Something. UNT start n total loop UNT start minus n. Actually, the results will be positive, but I don't know why it's become negative. It should be positive. Okay, it should be positive. And oh, this is the reason is n minus start. Okay, minus start. So from time to time, you must remember you must not remember, don't need to remember, to look at the formula. So the formula is loop multiplied by the time taken for loop plus with n minus with start, minus with start. Okay, so you got 20,000, 200,000, 200 million, sorry, 200 microsecond, 200 microsecond, which is equal to 200 millisecond, 200 millisecond, 200 millisecond, because the pulse to toggle is 100 millisecond. Yeah. So if I put here 50 compile, so you got 100. Okay. Okay, now we try another one. I will modify it a bit. Okay, I will modify it a bit. So we used to measure the period. We used to measure the period. All right. So okay, we look at this one. Okay, now we got 100 microsecond. 100 microsecond. 100 millisecond equal to 100,000 microsecond. Okay, so now we go back to the input capture mode. Okay, go to the time to go to the parameters. Parameters. We set to both edges, then reconfigure. Okay, reconfigure. So now remember, when for both edges, I mean rising or falling, then it will trigger, right? It will trigger. So when we go to the code, the main, right? The main. So, oh sorry. So when we go to the main, right here. So when it is interrupted, okay. So what we do, is to no more. Now we check for the start cap, no more. Now I just close this one for reference. So when it is interrupted, then we check the pin, if if what HAL underscore GPIO underscore pin underscore read, what pin A, pin number 0, right? Pin 0 equal, okay, we want to positive, we want to read this one, the period. So of course the period, wait a sec, okay. So the period when is interrupted, I mean for falling for rising edge, that means when we read it must be high, okay. So we start when it is equal to high. You can use one, you can write 1, or you can write on GPIO underscore pin underscore set, set. Okay. Then if you set, then you do something. You do what? You copy the start. Okay. Copy this one, and then set a loop. Copy, same loop, and then if else, you can use else, if, right? open brackets, copy this one, place it here. So when it is reset, that means if we refer back to the to the timing, that means when it's trigger here for falling, so the line become low. So when it's reset, okay, then we write this code. And you need to copy this one first, whatever it is, copy it first, then calculate the total. Right? I think this one we minus with, okay, forget it for time being. All right. Then we print F and print. Copy and print. All right, now I compile. Of course, we have warning, okay, to warning, because you start, then run. Okay, now you see we have 51000, right? 51000. Now, in the formula, we modify. This one is modification. It's not the formula. It's depend on your processor. I minus by 5000. 1000. Yeah, 1000. 1000. All right, now I compile. And if I run, then you got the team is 50, 50. Should be 50 here. Yeah, 50 millisecond, because here is toggle at 50 millisecond. Okay, that's all, boy. Okay, bye bye.